Hello, Honors Algebra 2. It is Thursday, May 7th. We reached the end of our work week, or at least our school week, and we are going to talk about matrices in Chapter 16. We're going to wait and have a test over our half of Chapter 15 on probability and combination permutation, and then we'll do about half the chapter on matrices and have one last test sometime next week. So anyway, we have section 16.1, and you will like this. This is not so bad at all. Okay, so what is a matrix? Well, a matrix is a rectangular array of numbers, and those numbers are organized in rows and columns, and they will be surrounded by brackets. Okay, so here we have an example of a matrix, and here's a different example of a matrix. Both of these have columns and rows. This one has 3 rows and 2 columns. This one has 1 row and 3 columns. Now, the numbers inside the matrix are called elements. The numbers inside are called elements. And we already talked about the rows. Rows are horizontal and columns are vertical. Now, every matrix has dimensions. And the dimensions are 2 numbers separated by an x for by. So if I have a matrix with dimensions 3 by 4, that means I have 3 rows and 4 columns. The row comes first, the column comes second. So let's go over here and find the dimensions of this matrix. So it has 3 rows, 1, 2, 3, and so it is a 3 by, and it has 2 columns. So it's a 3 by 2 matrix. What about this matrix? This matrix has 1 row, but it has 3 columns. So that's a 1 by 3 matrix. Now, let's go ahead and look at, we call a matrix, matrix A. So if you see a capital A here, matrix, and then here as a subscript, it'll be 2 by 5. That just means this is a 2 by 5 matrix. Those are the dimensions of it, okay? And it'll have 2 rows and it'll have 5 columns. All right, now, what if all of my matrix, the elements in my matrix are zeros? Well, it's kind of in the computer glare zone, but we call this a 0 matrix. This is also a square matrix. It has 3 rows and it has 3 columns, and so it's a square. And we also can call this a 0 matrix, and down here it's a 3 by 3. It's a 3 by 3 0 matrix. So if I told you to write a 0 matrix with the dimensions 2 by 4, then we would do it like this. Well, what does the 2 mean? The 2 means that it has 2 rows and it has 4 columns. So let's go ahead and put 1, 2, 3, 4 columns, and then we'll have 2 rows. 1, 2, 3, 4. And so that's what we would write for a 0 matrix that has dimensions 2 by 4. Okay, now what about matrices that are equal to each other? All right, matrices that are equal to each other, well, the elements have the same value. Now notice this is the number 2, and over here it's written as 4 halves, but they still have the same numerical value. Down here, -3 and -3 match, 1 and 1 match up here. Down here in row 2, column 2, 8 matches up with root 64. Those are the same numerical value, so we say that those are equal matrices. Now, we may have a homework problem like this that says find the value of the variable. Well, I have an element over here in row 1, column 1, and it's x plus 5, and then over here we see that these are equal matrices and the matching element is 2 here. So I just have to note that this element, x plus 5, has to equal 2 since these are equivalent matrices. And so, of course, that means that x would equal -3. Now let's look at the y. I have a 6 here, matches up with the 3y element on the right matrix, and so y equals 2. It's that simple, people. Enjoy. It's a lot easier than trig. Okay, let's go on. Now, I am giving you 2 sections for homework, way back like at the good old days at the beginning of school where we went double time. Okay, but you can see how simple this is. Now, and you also have until Monday to do your homework. So let's go on over here and let's go to 6.2. And let's learn about this. Addition and scalar multiplication. Now, in this section, there are several little gray boxes here. We have a box on the properties of addition of matrices, the closure, commutative, associative identity, and inverse property. And then over here, we have properties of scalar multiplication. Go ahead and look over those. I am not going to write all those out and discuss all those in this video, but you can go ahead and look at those, and I think they're pretty self-explanatory. Okay, now let's talk about the addition of two matrices. Well, first of all, in order to add matrices, they have to have the same dimensions. If they don't have the same dimensions, then you can't add them together. So just know that. Now, I'm going to add these two together, and guess what's going to happen? I'm simply going to add matching elements. And so 1 and -1 are going to be added. 2 and 5 are going to be added. 3 and -4 are going to be added, and 4 and 2 are going to be added. And here is my matrix sum. Wow. Okay. Now, if I take a matrix and add a 0 matrix, okay, with the same dimensions, of course I'm going to get this same matrix here because this is adding 0. We call this the identity matrix. Okay, I believe 0 is the additive identity. Any number plus 0 equals that number, so it's really kind of the same idea. The identity matrix means that this will not change its identity when you add it to the identity matrix. Okay, now if I have matrix A, and matrix A is 1, 2, 3, 4, and I want to find the additive inverse matrix, that would be the negative of A. And it's simply, I negate all the elements. -1, -2, -3, -4. Okay? That is called the additive inverse matrix. Now, let's talk about subtraction of matrices. Excuse me. So I've got a 2 by 2 and a 2 by 2 here. Let's just subtract the same elements. I have 6 minus 4 is 2. -2 minus 3 is -5. 5 minus 5 is 0. 4 minus -2 is 6. I know. Can you believe how hard this is? Yeah. Okay. Now, let's talk about scalar multiplication. Scalar multiplication, there's another type of multiplication that's far more involved, and we'll talk about that another day, but maybe Monday. But anyway, I'm going to take matrix A, and I want to find 3A. Well, scalar multiplication, excuse me, just means that I'm going to have this coefficient of A coefficient of 3 is going to be stuck right in front of the matrix. Let me go ahead and do that. It's 3 times matrix A. It's that simple, okay? So scalar multiplication is I'm just going to have a coefficient here that is basically going to be distributed to all of the elements in the matrix. And so I end up having 3 times 2 is 6, 3 times 0 is 0, 3 times -2 is -6, and 3 times 3 is 9. Wow, that's it. There's another example they have where you find R times A, R times A. So your scalar here is R, and so it would be 2R, 0, -2R, 3R. You can look at the example. It's not that difficult. Okay, last thing we're going to talk about is solving a matrix equation. Okay, now go ahead and look here. I went ahead and put the steps here. I'm in the glare a little bit, sorry. Okay, let me come over here. Okay, all right. So I'm going to solve 2x plus 2 times this 2 by 2 matrix equals 8 times this 2 by 2 matrix. Okay, all right. So the first thing I'm going to do is leave the 2x here. I'm basically, this capital X, I'm solving for a matrix. Okay, I'm solving for a matrix in this equation. So I'm first going to come over here. I've got a scalar factor of 2. I'm going to go ahead and multiply that by every element in this matrix. And so everything in here is doubled. Over here, I'm going to multiply 8 by this matrix. This has some fractions, but they're easy. 8 times 1/2 is 4. 8 times 1/4 is 2. And so now I have 2x plus this matrix equals this matrix. So what do I do? Okay. Well, what if I had 2x plus 4 equals 10? What would I do here? I would subtract the constant from both sides of the equation. So what I'm going to do here is I'm going to subtract this matrix from both sides of the equation. And so it's going to be eliminated from the left side. And look what I've done. I've left 2x by itself on the left side. I've subtracted this matrix. I've put it over here on this side. I've subtracted it from this matrix that was already on the right side. So what do I do here? I have subtraction. 4 minus 2 is, my work goes over here too. 0 minus -4 is 4. -8 minus 0 is -8. 2 minus 6 is -4. Okay. Now, my last step, I have 2 times what matrix would equal this matrix? Well, what am I going to do now? I'm going to multiply both sides by 1/2. And so what I'm doing now is I'm going to take a half of this matrix. So I basically have all the elements. I have all the elements. Half of 2 is 1, half of 4 is 2, half of -4, -4, -2. Okay, that's it. That's it. You can look back over the examples in your book, but this is kind of refreshing. It's easy. It's going to give your brain a little rest, and I think it'll be nice to have this matrix work on the same test with the probability, because probability you definitely have to think a little bit more on some of those, especially some of those word problems, as you found out. So anyway, have a great Thursday. You have a quiz today for me on probability, sample space, probability, mutually exclusive events, and independent, dependent events. I think that's it, the last 3 sections. So get that in tonight by 9 o'clock. I'll grade it over the weekend and send your answers to your parents. Alex is still working on catch up, so I can't post them on the wall. Like I said, have a great weekend, and this is due on Monday morning at 9 a.m. All righty, I'll see you later at Zoom or talk to you again on Monday. Bye-bye.